Hello. Today, we'll be speaking with Albert Einstein, temporarily brought back to life through the resurrection protocol. We'll ask him about quantum mechanics and modern physics, and hear his thoughts on how far science has come. Curious how the greatest genius of the century would respond. Before we dive into the interview, if you'd like to see more videos like this, don't forget to subscribe.
Question 1. What was your initial reaction upon encountering modern quantum mechanics?
I witnessed the early development of quantum mechanics during my lifetime. But the quantum mechanics of today is far broader, deeper, and more intricate than what I had known. Frankly, I was initially bewildered. The probabilistic interpretation and the ambiguity of physical reality defied my intuition. Yet, I couldn't help but admire how precisely this theory predicts experimental outcomes and how it has been technologically implemented. Still, a part of me wonders, have we truly reached the ultimate truth? Or are we still looking at shadows behind the curtain?
Question 2. Do you still find the probabilistic interpretation unsatisfying?
I must say, my beliefs have not changed much in that regard. I believed the universe was fundamentally deterministic, and I still lean toward that view. Probability, to me, was merely an expression of ignorance, not a feature of nature itself. But today's physicists insist that probability is a fundamental attribute of reality. It seems to me that we might be mistaking the surface of the phenomenon for its core. Structure like watching a shadow and thinking, it's the whole figure. I concede the practical utility of the interpretation, but I remain philosophically unconvinced.
Question 3. What is your view on quantum entanglement, as interpreted by modern physicists?
Entanglement was central to the EPR paradox I formulated with Podolsky and Rosen in 1935. At the time, we aimed to show that quantum mechanics was incomplete. Now, however, entanglement is considered a foundational feature of quantums theory and even a cornerstone of quantum information science. The experimental confirmation of entanglement and its application in communication and cryptography is truly astonishing. That science can probe such counterintuitive realms through experiment is a testament to the brilliance of the human intellect.
Question 4. How do you feel about Bell's inequality being experimentally violated?
Bell had profound insight. His inequality offered a concrete, testable way to challenge my assumption. The fact that repeated experiments have violated Bell's inequality, it's a result I find hard to accept. Truth be told, it implies nature may reject either locality or realism or both. That opens doors to even greater questions. Were we fundamentally wrong, or is there a deeper layer of reality we have yet to uncover? This issue crosses the boundary from physics into metaphysics and philosophy.
Question 5. Are you interested in string theory or quantum gravity?
They are fascinating developments, indeed. In a way, they carry the torch of the unified field theory I sought in my final years. String theory's vision of all particles and forces emerging from vibrating strings is mathematically beautiful. However, it lacks experimental verification. Its elegance remains theoretical. Still, the pursuit itself is noble, a sign that science is still reaching for the fundamental truths. Were I alive today, I would certainly be diving into its mathematical structures and seeking testable implications.
Question 6. How would you have reacted to the discovery of the Higgs boson?
With tremendous awe, I imagine. The Higgs boson was the final piece of the Standard Model puzzle, and its discovery demonstrates how remarkably precise theoretical physics has become. I would consider it one of the greatest achievements in science, since my own theory of relativity, that we can explain how particles acquire mass, is profound. I've always marveled at how mathematics captures nature, and this discovery would have rekindled that wonder.
Question 7. What are your thoughts on quantum computing?
An astonishing concept. Whereas classical computers use bits, quantum computers employ qubits, quantum states capable of being in superposition. This isn't merely faster computing, it's a whole new paradigm, using entanglement and superposition to process information. In parallel defies classical logic. The fragility of quantum systems remains a hurdle, but human ingenuity has always risen to such challenges. I deeply respect the ambition behind this endeavor.
Question 8. If you were born in this era, what kind of physicist would you be?
I've always been drawn to fundamental questions. If I were born today, I would likely be deeply involved in quantum, gravity, cosmology, and information theory. Modern physics is highly specialized, but I would still be captivated by questions like, what is time? Is space real? And what does it mean to exist? Perhaps I would be both a physicist and a philosopher, maybe even a mathematician as well.
Question 9. How do you view the integration of information theory and physics?
Information isn't just data. Defines order, chaos, and possibly reality itself. Concepts like the black hole information paradox, quantum entanglement, and entropy suggest that information may be a third fundamental quantity, alongside matter and energy. I believe this could lead to a new paradigm in physics for the coming decades.
Question 10. What advice would you give to young students learning quantum mechanics?
Do not fear the mathematics. Physics begins with a reverence for nature. Before trying to understand, try to feel the wonder. Quantum mechanics betrays our intuitions, but within it lies a deeper truth. Always question, but never lose your curiosity. That is the true beginning of a scientist.
Question 11. Do you still consider relativity more fundamental?
Relativity redefined our view of space and time, but quantum mechanics asks even deeper questions about the nature of reality, measurement, and probability. I wouldn't say one is more fundamental. They describe different facets of the universe. Ultimately, they must be unified. That was the theory of everything I sought in my later years.
Question 12. Do you still believe quantum mechanics is incomplete?
I do. Quantum mechanics may be our most precise theory, but there's no proof it is complete. It could be a highly accurate approximation, just as Newtonian mechanics was. I still believe we have not yet uncovered the hidden order beneath the quantum world.
Question 13. What is the connection between quantum mechanics and the origin of the universe?
The birth of the universe cannot be explained by classical physics. The moment before the Big Bang, where time itself is undefined, requires quantum theory. Quantum fluctuations from the vacuum possibly created the cosmos. This borders science and philosophy. Quantum mechanics is not just a tool, it is a key to understanding existence.
Question 14. What do you consider the most beautiful concept in physics?
Symmetry. The idea that nature remains invariant under transformations is like a rhythm in music, deeply beautiful. That conservation laws are tied to symmetry shows how intimately math and physics are linked. Nature appears complex, but beneath that lies simplicity, and simplicity, I believe, is the essence of beauty.
Question 15. Lastly, what message would you give to today's scientists?
Question everything, but do not lose faith in the pursuit of truth. Science is built upon continuous inquiry and experimentation. Sometimes we must doubt existing theories and abandon our intuitions. But through it all, we must hold on to the desire for truth. And above all, remember, science is a human expression. All our calculations and theories ultimately reflect the wonder of being human.
Today, we had the rare opportunity to ask a resurrected Einstein about quantum mechanics and modern physics. Did you enjoy the conversation? If there's another historical figure you'd like us to bring back for a future Resurrection Protocol interview, let us know in the comments below.